Hi everyone, welcome to On Point. In this video we are going to discuss about centrifuge, so without any delay let's start the video. Centrifuge. A centrifuge is a device that uses centrifugal force to separate various components of a fluid. Principles of centrifugation. A centrifuge is a device for separating particles from a solution according to their size, shape, density, viscosity of the medium and rotor speed. Within a solution, gravitational force will cause particles of higher density than the solvent to sink, and those less dense than the solvent to flow to the top. As the rotor spins around a central axis, it generates a centrifugal force, acting to move particles away from the axis of rotation. If the centrifugal force exceeds the buoyant forces of liquid media, and the frictional force created by the particles will sediment. Types of centrifuges and their uses. There are four major types of centrifuges. They are: small bench centrifuges. They are used to collect small amount of material that rapidly sediment like yeast cells, erythrocytes etc. They have maximum relative centrifugal field of 3000 to 7000 G. Large capacity refrigerated centrifuges. They have refrigerated rotor chamber, and have capacity to change rotor chambers for varying size. They can go up to maximum of 6500 G and used to sediment, or collect the substances that sediment rapidly like erythrocytes, yeast cell, nuclei, and chloroplast. High-speed refrigerated centrifuges. They can generate speed of about 60,000 G, and are used to collect microorganism, cellular debris, larger cellular organelles, and proteins precipitated by ammonium sulfate. Ultracentrifuges. A. Preparative ultracentrifuge. It can produce relative centrifugal force of about 600,000 G, and its chamber is refrigerated, sealed, and evacuated. It is employed for separation of macromolecules or ligand-binding kinetic studies, separation of various lipoprotein fractions from plasma, and deproteinization of physiological fluids for amino acid analysis. B. Analytical ultracentrifuge. It is capable of operating at 500,000 G. Three kinds of optical systems are available in analytical ultracentrifuges: a light absorption system, and the alternative Schlieren system and Rayleigh interferometric system, both of which detect changes in the refractive index of the solution. Design and types of rotors. Swinging bucket rotors. The swinging bucket rotor has buckets that start off in a vertical position, but during acceleration of the rotor swing out to a horizontal position, so that during centrifugation the tube, and hence the solution in the tube, is aligned perpendicular to the axis of rotation, and parallel to the applied centrifugal field, the tube returning to its original position during deceleration of the rotor. Fixed angle rotors. In fixed angles the tubes are located in holes in the rotor body set at a fixed angle between 14 degrees and 40 degrees to the vertical. Under the influence of centrifugal field, particles move radially outward, and have only a short distance to travel before colliding with, and precipitating on, the outer wall of the centrifuge tube. A region of high concentration is formed, that has a density greater than surrounding medium, with the result that the precipitate sinks, and collects as a small compact pellet, at the outermost point of the tube. Vertical tube rotors. They are considered as zero-angle fixed-angle rotors, in which the tubes are aligned vertically, in the body of the rotors at all times. Zonal rotors. The zonal rotors may be of the batch or continuous flow type. The former being more extensively used than the latter, and are designed to minimize the wall effect that is encountered in swinging bucket and fixed angle rotors, and to increase sample size. Elutriator rotors. The Ultrator is a kind of continuous flow rotor, that contains recesses to hold a single conical-shaped separation chamber, the apex of which points away from the axis of rotation, and a bypass chamber on the opposite side of the rotor, that serves as a counterbalance, and to provide the fluid out. Sample containers. Centrifuge tubes and bottles are available in different range of sizes, thickness, and rigidity from different variety of materials including glass, cellulose, esters, polyalumer, polycarbonate, polyethylene, polypropylene, kynar, nylon and stainless steel. The type of container used will depend upon nature, and volume of sample to be centrifuged, along with centrifugal forces to be withstood. Glass centrifuge tubes are suitable only for centrifugation, at low speeds as they disintegrate at higher centrifugal fields. Thin-walled tubes may be used in swinging bucket rotors, because the tube is protected by the surrounding bucket. However, thick-walled tubes are required with fixed angle, and vertical tube rotors. The centrifuge tubes should be filled to accurate level, and need to cap the tube, or bottle depends upon the speed, and type of the container used. That's all for now. For more updates please do like, share, and subscribe. See you in next video. Thank you.